Okay, we have a few stragglers outside that need to be persuaded to come in. I'm wondering if I should go there personally and use the same technique I use with my students. Thank you so much for being here today. We are moving towards a close of the conference. I hope you're having a good time. A couple of quick announcements and then I'll let you go. I know that rumors are spreading. Where are we going for the boat? There is a boat announcement on the website and it says Cabotage. And there is a link and it gives you the directions. So the boat will be leaving from Cabotage and it will be returning from Cabotage. And then, once you get there, you can take taxis, public transportation, or walk and whatever, and get back to wherever you would like to go. So do not listen to the rumors that say that there are alternative venues. The different piers that you see on the programs are the different piers of Istanbul, to make it easy for you to go to Broken Stillness, which is on the other side, on the Asian side of the other exhibition. And generally speaking, you know, you can go there from 10 to 5. Now, having said all of this, I believe that we have had so far a very good series of speakers, but I'm saving, you know, one of the best for the last days. And I want to introduce briefly somebody that I believe has made a great contribution to the digital media art scene, and it's a great pleasure to introduce to you Sara Diamond. Thank you.
I'm really honored to give a keynote at IZEA 2011, and I thank Sanfredo Acito and Austin Sahin for this invitation, and I congratulate you on this amazing event. In 1997, I had taken up a performance persona as a zebra, an animal that seemed a perfect cathesis for debates about art and science, with its clonal mosaic pattern pelt, evolutionary stamina, and creature stubbornness. Turing's calculations of patterns and intelligence through reaction diffusion were inspired by the zebra. The performances embraced and critiqued anthropomorphism, or more appropriately, zoomorphism, engaging in ritual clowning in which the zebra could make statements about the emerging culture of art-sci and the desire for bonding between artists and scientists without reprisal. When I was commissioned by Peter Wright to build a website to contain art-sci dialogues, I realized that my site required chat. The inert and linear qualities of IRC and the impossibility of building dynamic dialogues within these prompted the decision to create a visual and nonlinear chat tool. And John Tonkin, who's in the audience, is in part to be blamed for the first iteration of the project. So Irving Goffman emphasized the ways that conversation, a form of everyday performance, establishes a participation framework for sociality, an insight borne out by the growth of social media in this decade. I was struck by the emotional, affective qualities of individual posting and interaction, and the ways that emotions appeared to impact participation and relationships. I sought a means to visualize the emotional nuances of, as Goffman puts it, movements, looks, vocal sounds, and speaking. At the same time, social media could act as a collective memory, providing a viable tool for both real-time and archival use. These interests led me to create the CodeZebra OS, an online tool for collaboration, initially between the arts and sciences. It brought a lateral, collaborative structure to the linear hierarchy of chat. The system included casual language games that users could defer to when conversation became heated or overly somber. The aesthetic of the software self-consciously imposed a zoological and decorative beauty to online discourse. Seeking links between data and their sources in biological sciences, zoology, human physical experience, and overall materiality. Lushness was meant to connect the software to the physical world eventually quite literally, because the larger project created interactive sensor-laden software, WEAR, very corny, garments that responded to the operating system, dance performances, and habituation cages, a joke about Pierre Bourdieu's notion of the habitus, in which artists and scientists were locked up together for 24 hours under rigorous surveillance and expected to produce new discoveries or theories. To represent multiple affective states, this is a locked-up scientist, I built 8 other distinctive creatures, loosely grouped using a system similar to the plot-shit model of emotions, all with Voronoi pattern skills in a relational ecology. The structure of Voronoi patterns, conveniently similar to early Java prototypes, meant that every time a posting was added, the visual chat world readjusted the worldview. Extensive user testing showed that grasping a reading of each animal pattern was near impossible and not intuitive for users. But once they learned how to play with CodeZebra OS to manipulate and tone conversations, they embraced it. So these are several of the prototypes. Give you the feel for the look and the feel. Invoking reaction diffusion inevitably led me to considerations of scientific aesthetics that privilege simplicity and symmetry. I knew CodeZebra OS was cognitively challenging, but I liked it that way. And in examining a wide number of visualizations created by artists, designers, or computer scientists over the last decade, I found on one hand a shared data structure, set of data structures of course, but also tropes and metaphors, and a resistance within some scientific discourse to the effective, beautiful qualities of these metaphors. There was a resounding imposition of natural metaphors, even when the source code, like mine, had no relationship with nature. For the first time in human history, infinitely precise scientific instruments, the digitization of analog materials, and the explosion of digital storage capacity, processing power, and the internet have produced massive quantities of data, such as consumer buying patterns, text corpora, genomic or cosmological data, posing unique challenges. In this era of big data, access to sources and appropriate tools to analyze is as important as water and oil. The growth of cloud computing, visual search engines, the penetration of fast broadband and wireless networks have all created an ideal environment for the explosion of capacity in data visualization. Data visualization is growing exponentially in scientific, social science, and even humanities research, as well as in commercial applications such as social media. Our expectations of the intelligibility and accessibility of data have shifted with the growth of databases and search technologies. This situation creates an expanding demand for tools and expressions that facilitate finding information and analysis. In the last decade, strict prior separations between scientific visualization and information visualization have eroded. Firstly, entirely new practices that cross the boundaries of information and science, such as genomics and bioinformatics, have come on stream. And these fields rely on data visualization to execute structures in large-scale data sets. They have no photorealist technologies to fall back on. And secondly, as Lev Manowitsch has remarked, data visualization allows representations to be mapped onto each other to compare and overlay vastly different data sets, permitting the representation of infinite permutations and complexity. And this map's kind of good to look at for that. For these reasons, my university, the Ontario College of Art and Design, OCAD University, York University, and the University of Toronto have created the Center for Information Visualization and Data-Driven Design, or D to the power 3, a research hub for the development of next-generation data visualization techniques and their underlying information processing and communication technologies, in partnership with communication industries, the financial sector, green tech and ITC partners, biomedical researchers, and physicists. The range of partners suggests the vast territory of data visualization applications that have emerged. This interdisciplinarity also requires attention to questions of design, aesthetic histories, and methods, which we have built into the framework of the project, and it has 12 artists and designers and kind of match and complement of computer scientists, data extraction scientists, visualization scientists, and vision scientists as well as our partners. So aesthetic structure experiences in formal, perceptual ways and provide interpretive tools, at times constructing meaning. Given that sensory expression, most often visual, sometimes sonic or tactile, is the only means to perceive many contemporary data sets, aesthetics are fundamental, not additive to the emerging field of data visualization. Data are mathematical, comprised of a set of organized measurements created by instruments that calibrate quantifiable qualities of an original source, whether natural, artificial, or recombinant. Data sets are shaped by prior decisions, such as the instruments choosing to collect the data, the structure of the database, source and sampling methods, and software choices. An example of a pipeline for one of our projects, and I'll leave this up there as I talk. These elements implicate data and put a mediating framework around notions of objectivity. The data source remains present, hovering as a ghostly presence, and yet is translated by the digital, and is always part lost in translation. Aesthetic realism implies exactitude, where in fact there may be ambiguity in the data. Data are a mediation of actual phenomena, an immaterial material, a contradictory mix of abstract points or numbers and producing phenomena. And data only become information when they are placed into an interpretive context. This requires building algorithms that allow for selection, extraction, organization, analysis, and presentation. It is the representational act of transforming both data and data structure into a visualization interface that allows the user to interact with the data. And the resulting images create a bridge between the empirical world and the viewer, revealing patterns of the source data that evoke interpretation. Visualizations do allow the comparison of a set of values, the illustration of relationships between data points, the indication of the parts of the system and the relationship and interaction of these parts, the creation and interpretation of maps, the tracking of change over time, the analysis of text, etc. I believe that data visualization offers the possibility of fundamental new insights, a moment of understanding that reveals hidden processes or complex relationships, breaks through existing barriers, and sharpens the focus on knowledge while providing visual pleasure. In an article entitled "The Petabyte Age," Wired magazine declared the end of science. It generally likes to declare the end of things like television and other kinds of ends, and not always with success. A bit of, perhaps, arrogance. Editor Chris Anderson argued that scientists must end hypothesis and experimentation. It's a hard thing to pitch to the science community, but in any case. Instead, science must move entirely to data analysis derived from big data sets that lie beyond the natural limits of human comprehension and require, quote, dimensionally agnostic statistics, unquote. The more scientists learn about physics and biology, he argued, the harder it becomes to create testable models. Instead, Anderson states, researchers must search for patterns and relate these to the data source in order to find a fresh analysis, working with pattern recognition and theorization from the abstract back to the material world. It's very elegant. And while I actually agree with this observation on the potential for new discovery, Anderson's view proposes big data as providing the means to rescue science from subjectivity and speculation, offering a reversion to scientific realism and objectivity in which data stands in for the real. The tenets of scientific realism propose that there is a universal shared world of perception that makes up common sense, and discovery then manifests this world through shared understanding. The aim of science is to accurately describe reality. The empirical world, including its invisible dimensions and its description through analysis, becomes of paramount importance. The rationalist roots of scientific realism suggest that perception leads directly to action.